Welcome to this web lecture on optimization and transport, the road to linear programming. Today I'm going to walk you through the steps towards linear programming, and in a follow-up lecture we're going to look into how to get from linear to integer linear programming. So throughout these two blocks we're going to look into an example of a barge, which is a ship like you can see on these pictures. First, that transports sand and coal, and then a second step that transports containers. So, in our example, a barge can transport sand and coal at revenues from 100 tons and 150 tons from Antwerp to Rotterdam. The total capacity of our barge is 225 tons. Currently, only 120 tons of coal are available in Antwerp, which means we can also not ship more than 120 tons. Loading 1 ton of sand takes half a minute, while loading 1 ton of coal takes 1 minute. In total, the barge must be turned over in 2.5 minutes, which just means that we have to load everything within the 2.5 hours. So, what are we doing? So the first thing is, what is the problem that we're trying to solve? The problem that we're trying to solve is we're trying to find the revenue optimal amount of sand and coal to transport. Secondly, what do we need to consider? If we want to solve this problem, we have to consider the capacity, so the 225 tons. We have to consider the coal availability of 120 tons, and we have to consider the loading time, so that we have to turn over this barge in 2.5 hours. Thirdly, how can we solve this problem? So for now, we're going to solve this problem visually by using two variables. So how are we doing this? We're going to set the amount of sand and the amount of coal as axes in the coordinate system. So here you can see sand as the x-axis and coal as the y-axis. Secondly, we're going to put in the constraints that restrict our problems. So in our case, we have this capacity constraint. So sand plus coal has to be less than or equal to 225 tons. So even if we only ship 100 tons of sand and 110 tons of coal, that would be completely okay with this constraint, because we're still less than or equal to the 225. And this is what you can see in this shaded blue area in here. Secondly, we're putting in the availability constraint. So we're saying coal has to be less than or equal to 120 tons. And as a result, you can see that this shaded blue area, which we call the feasible area, is shrinking. It's getting smaller. Now we're going to put in the third constraint, the loading time, which says 0.5 times the amount of sand that we're shipping plus the amount of coal that we're shipping has to be less than or equal to 150. 150 is just 2.5 hours if we look at it in minutes, which once again reduces this feasible area. So what is the next step that we have to take? Now we still have to determine what actually the revenue optimal solution is in this system. How are we doing this? So we're going to plot this objective function, 100 times sand plus 150 times coal, for different values. So we're going to set this to equals to 10,000, 15,000, 20,000 and so forth. And this is just the first line that you see here in gray. Then we're putting in the second line. We're still very good. We're still absolutely feasible in here. We're going to go for the third line, for the fourth line. And now already you see that some of the feasible points are actually can no longer be optimal. And now we're going to look at the final point. So we're just pushing it a little bit further up to the point where the loading time and the capacity constraint intersect. And this gives us the optimal solution, which is 150 tons of sand and 75 tons of coal as the optimal solution. We could alternatively also just evaluate all corner points of this feasible area, so of this blue polygon, and then one of them is going to be the optimal solution. So we just have to evaluate how large the objective function value is in each of them and choose the one which has the highest value. So what would I like you to take away from this lecture on the road to linear programming? So the first thing is, please keep in mind the sand and coal transport example, because it's going to come up in multiple follow-up clips. Secondly, I would like you to take away what the graphical solution is. But what we are going to do in the next lecture is first we're going to look into how to formulate this in a little bit more general case. Then we're going to look into some special cases, once again using the graphical solution. And lastly, we're going to look into so-called soft constraints, which is just a special way of formulating stuff.